Okay, so today we're talking about complex numbers. We're just going to go a little bit more in depth. So I'm going to start with a little bit of a review first. So let's review some more radicals. So I could simplify this by splitting it up. Isn't this just 16 times 2 over root 6? What's wrong with this? Excellent. That's exactly what I wanted to hear. There can't be a radical in the denominator. So don't I have to multiply by root 6 over root 6? Why can I do that? Because root 6 over root 6 equals 1. That's why I can do that. So once I do that, I've got, well, let's just simplify that. That's 4 root 2 times root 6 over root 6 squared, which is just going to be 6, right? Keep going with this. I've got 4 root 2 times 2 times 3 over 6. 2 gets kicked out, right? So I have 8 root 3 over 6. Am I done? This is 4 times 2 over root 3 and 2 times 3. The 2's cancel. 4 root 3 over 3 will be my final answer. That's a review. Some of you are copying this down, so I'm going to go ahead and pause it. Okay, so let's make it a little more complicated. What if I had 2 over 1 plus root 2? Can I multiply that by root 2 over root 2? No, because if I were to do that, I would get root 2 plus 2. That doesn't get rid of my square root. What? I can't do that. Anybody remember what you can do? Yes, Mo. I would multiply by the conjugate. 1 minus the square root of 2. The reason for that is, I'm going to show you right now. Okay, this is a side note. Changing my color. What is this? The difference of 2 squares. The reason it's the difference between 2 squares is because if I FOIL it, my center numbers cancel each other out. Remember that? This is the same idea. So watch. This is also the difference of 2 squares. Correct? I'm going to do it both ways. The difference of 2 squares. What's my first term? What's my second term? I'm going to leave that there for a second. Let's FOIL this. What's that? 1 squared. What's this? Negative root 2. And this? And this? Negative the square root of 2 squared. Correct? Root 2 times root 2? Everybody follow me? No?
I get 1 by 1 by negative 2 when we're going to square root 2 now.
I'm doing it for a reason. Right? It's root 2 times root 2. There's a negative there, right? There's a negative there, correct? Root 2 times root 2 is root 2 squared, correct? These cancel out. Isn't this the same thing? Right? Aren't they the same? So do I really need to FOIL that whole thing? Or can't I just do this every time I see a conjugate? Make it the difference of two squares.
Would it always be minus?
Yes. What are these? What goes here? What goes here? X squared minus 4. See how I did that? Another one? Hold on. People are letting this sink in. Don't let questions at this point bog them down. What is this one? X squared minus 49, right? Or the difference of two squares where x and 7 are my numbers. See how I'm doing that? Yes. Yes. I'm going to do it till it's going to click. Watch. X squared plus 7x. Oops. So it's the difference of two squares. Minus 7x plus 7x minus 49. These cancel out, right? Another one? Let's make it more complicated. What about this one? Difference is two squares still, right? What's my first term? Or 2x squared and y squared, which is 4x squared minus y squared. No, not yet. This one? I'm doing the same exact thing. I'm going to do it again. We're going to do them side by side. Okay, is this are these conjugates?
Yeah.
So are these, right? Right? Here's the difference. We say difference because it's the difference between them, right? Here's two squares. This one's also going to be, please stop talking. This one's also going to be the difference of two squares. What's my first term on this one? X. What's my first term on this one? 1. What's my second term on this one? 2. What's my second term on this one? Radical 2. See it now? So with this one it's x squared minus 4, and with this one it's 1 squared is 1 minus, what's the square root of 2 times? Right? Yes. What is what 2 for? Here? The original problem. Here's your original problem. We can't have a square root in the denominator. So we're multiplying by the conjugate because we just found the denominator right there. That's all we found right now is the denominator. Let's start off brand new. If I have 1 over 2 minus the square root of 2, what would I multiply by? 2 plus root 2. I'm going to do this one all the way through this time, okay? This is the difference. First, let's do the numerator. I'm going to do it in different colors. Here's the numerator. You don't need to write this down because this is not what we're doing today. This is review. Yes. Number 1. This is my numerator. 1 times 2 plus root 2. It's just been a while since you've seen it. We're not going to be concerned about that one right now. Please stop. 1 times 2 is, you guys, seriously, there's a lot of people in here that are confused, and you've got to not ask questions while we're talking. You know what I mean? Because you're interrupting the process right now. I'm going to start over again. Nobody say anything, okay? Because there's a few people in here that are getting frustrated because they're already lost. So let them process this, okay? All right, so I'm going to use my numerator first. So I'm going to multiply 1 times 2 plus root 2. Let's change that. Make it a little more complicated. Well, I mean, if I really want to show you how to do this, right? That was too easy. All right, so 2 times 2 plus root 2. 2 times 2 is 4. 2 times the square root of 2 is 2 root 2. There's my denominator. 4 plus 2 root 2 equals. Now I'm going to find my, did I say denominator? Sorry, that was my numerator. Now let's find my denominator. Here's my denominator, right here. 2 minus the square root of 2, 2 plus the square root of 2. Difference of 2 squares, where 2 is my first term and the square root of 2 is my second term. 2 squared is 4 minus the square root of 2 times is 2, so 4 minus 2 is 2, is my denominator. But I'm not done, because everybody's got a 2. So I've got to take a 2 from him, 2, 2. My answer is square root of 2.
Yeah, the other 2 root 2 from a 4.
Thank you. Thank you, thank you. 2 plus root 2. Okay, are we on? Okay, so are we okay with that? All right, it's going to get easier, and actually when you use eyes, it gets even easier. Yes. I did. We did it a couple times. I'll show you again. 2 minus the square root of 2. 2 plus the square root of 2. 2 times 2 is 4, plus 2 root 2, minus 2 root 2, minus the square root of 2 2 times. These cancel out, and I have the same thing as right here. See it? They're the same thing. So I have 4 minus the square root of 2 twice is just 2, which is 2. Okay, I'm going to move on. All right? All right, so let's talk about complex numbers now. What did we say yesterday complex numbers look like? Conceptually, what do they look like? What about I? It's the negative area, right? Where I've got the area, if the area is -1, then the sides must be negative root 1, right? Or, which is equal to, I also said, the square root of -1 is I, which is I squared. Therefore, these two are equivalent. -1 equals I squared. That is what we did yesterday. We also said that I to the 0 equals 1. I to the 1 equals I squared equals -1, and I cubed equals -I. Good. What about this? square root of negative 1 times 16 times 2, right? Times 4 root 2. This is really I, correct? Or 4I root 2. Let's do something a little bit easier. What would this be? 6I. What would this be? What would this be? You guys getting it? All right, go ahead and write this down. Okay, so let's look at this first one. Pencils down. I'll let you write in a second. So what would be my first step in solving this? Well, I would subtract 100 from both sides first. You could do that too. Then I have 4x squared equals negative 100. Now I can divide both sides by 4. X squared equals negative 25. Take the square root of both sides. X equals plus or minus 5i. There's a negative. Yes. If it was negative, right? If it was negative 100, you would have 2x plus 10, 2x minus 10. Correct? But it's not. Where did the plus or minus come from? Good question. If I have x squared equals 25, what is x?
What?
Isn't it 5?
Yeah.
Because 5 squared is 25? Check this out. Right? But Bassam, what if it was negative 5? Wouldn't it still be 25? Because negative 5 times negative 5 is positive 25. So you have to consider both cases.
Very smaller.
What?
Scary.
What's scary?
No, I said that's scary good.
What, just came up with an example like that to explain it?
Yeah.
Good. All right, you guys. So go ahead and copy that example down, please. All right, so it looks scary, but it's not that bad. Find the values of x. Find the values of x and y that make the equation true. So my first step is to set up the real parts equal to each other. All right, remember in the very beginning where we put the real parts together and the imaginary parts together? Well, this time we've got an equal sign. Whenever you have an equal sign, it means that something on this side equals something on this side. And something on this side equals something on this side. See how these are both have I?
Yeah.
So I'm just going to set them up equal to each other. So I have 5x plus 1 equals 2x minus 2. This one I could write out. Let's just go ahead and write it out just like it looks, and I'll show you why it works. If I have an I on both sides and I divide it by I, wouldn't that just go away? Okay. Okay. So I'm going to subtract 2x from both sides and subtract 1 from both sides, and I get 3x equals negative 3, or x equals negative 1. This side I'm going to subtract a y from both sides and subtract a 3 from both sides, and I get y equals negative 9. Those are my two solutions. Write that down. If I were to substitute negative 1 back in both of these equations, and if I were to substitute negative 9 back in, both sides would be equal. That's what that means. All right, so pencils down. Everybody pay attention. Let's do this one. You tell me if it's easier or harder than the last ones we did, okay? So I need to multiply by the conjugate, right? So I'm going to multiply by 3 minus 5i. 3 minus 5i. This is the conjugate, right? I have 3 plus 5i, so I'm going to multiply by 3 minus 5i to get rid of my imaginary underneath. Okay, so let's start with my numerator. My numerator is negative 2i times 3 minus 5i. Negative 2 times 3 is negative 6i. Positive 10i squared. Negative 6i plus 10 times, I know I squared is negative 1. I want my real stuff to go in front and my imaginary stuff to go in the back, so I have negative 10 minus 6i.
Is the I not next to the first or the second?
Exactly. We can't do it. No, that's my numerator. Right? Now I'm going to find my denominator. I multiplied that by that.
But why wouldn't the negative 6i be like 1? It's the negative, like the I to the first power.
Which is I. I, the first power is I, right? So you can't do anything else with it. You can't do anything with an I unless it becomes squared, and then once it becomes squared, it becomes negative 1, which is what's going to happen down here. So my denominator is, let's move this out of the way. My denominator is 3 plus 5i times 3 minus 5i. Difference of 2 squares. Correct? Where 3 is my first term and 5i is my second term. So 3 squared is 9 minus, I have to distribute that square to both, right? If this is 5i squared, then isn't that 5 squared I squared?
Yeah.
Okay?
25i.
Which is 9 minus 25i squared, which is,
Oh yeah, 25 negative 1.
which is 9 plus 26, which is, oh, sorry, 25, sorry. I was wondering about that for a second there. I'm like, I don't remember it being 35. I remember it being 34. There's my denominator. I'm not done, though, because I've got 2's in there, right? I've got a 2 in here, becomes 5. I've got a 2 in there, it becomes 3, and I've got a 2 in there, and it becomes 17. Just like this, guys. Here's an example of that. Example. Check this out. What if I had 2x plus 4 over 2? If I divide everybody by 2, isn't that x plus 2? I just did the same thing with this. I'm not done yet. Let's put this right here. I'm not done yet. So, isn't this negative 5 over 7? I got to put my real parts together and my imaginary parts together, right?
Yeah.
Minus 3 over 17i. Just like if I had x plus 2 over 5. Isn't that equal to x over 5 plus 2 over 5? Jesus. I did what?
No.
10i squared is 10 times negative 1, makes negative 10. Do you see it? Do you see it, though? Yes. Right here? I skipped a step. I have negative 5 minus 3 over, 3i over 17. Right? Is that what's left over? I'm going to split them up. Just like this, if I had x plus 2 over 5, that means x over 5 plus 2 over 5, right? Does it? I can split up a fraction like that, right? Yes. Because I need my real parts together and my imaginary parts together. These are stuck together, real and imaginary, being divided by 17. I need it to be separate. Let's do another one. How about, yes.
The last step you did, is that a minus equal?
Yes.
Looks like that.
I think we need another visual. How about negative 4 minus x over 6? That's negative 4 over 6 minus x over 6. Yeah?
We have to do that?
Yes. Yes. Everybody okay with that? Yes. This one would cancel and it would be negative 2/3. No. Nope. That would be perfectly simplified form if I was given this. That would be completely simplified. This, right here. You've got to break it down like that. All right, let's do some homework together, yeah? All right, so, oh wait, we still have the ones for you guys to do.
Oh.
We have got 15 minutes. You want to do it on whiteboards? You can do it on whiteboards. You've already, did you guys write this one down? Okay, you need to write this one down. All right, so give you guys a chance to do this one. Subtract 4 from both sides, and you get x squared equals negative 4. Take the square root of both sides, and you get x equals plus or minus 2i. Questions on that one? This one's a little bit harder. Do this one. 2, 1. All right, so this one was a little bit more ambiguous. I've got 2m is equal to, what's the part over here?
6.
Yes.
I'm so good.
3n plus 1 matches negative 8. So I have 2m equals 6, which is m equals 3, and 3n plus 1 equals negative 8. I don't need the i's because they cancel each other out. Subtract 1, 3n equals negative 9. Yes. I didn't use
before you bring it back to your desk.
That would be way too smart.
I gave you an extra watch.
Okay. Questions on this one? Yes, Evan.
Why did you put the 2 and put the 8? Just like curiosity.
Guys, I need it to be quiet for a second. Because this is really, I mean, I could rewrite it like this. 2m plus 3n plus 1i equals 6 plus negative 8i. Isn't that the same thing?
Yeah.
Now do you have these parts matching and these parts matching? You see that? I just put the negative 8 in parentheses like that. Yes. I know. Did you do it a different way? Not that I know of. Yes.
The eyes cancel one cause and one negative.
No. Quiet down, please. The reason the i's cancel is this. If you were to divide both sides by I, what would happen? They would cancel. More? Hold on. Let's use this teachable moment. What if I had right? And I divide by x, don't they both go away? Evan.
When you cancel out the i's, what do you keep, like, dividing it by everything?
What?
Like, it's 2n plus the parentheses thing times I, so when you cancel out, you have to divide
You guys, there's people asking questions and then there's people talking. Evan, say it again.
Wouldn't you have to divide everything by I in order to cancel I out?
No, that's why we're doing this part equals this part. The real equals the real, and the imaginary equals the imaginary.
Oh, because I thought it was all one thing.
No. Okay? Last one. You guys try this one. All right. So, did you just say no and growl at me? All right, so I need to multiply by the conjugate, so that's 1 plus I. Bless you. 1 plus I. So, hold on. I'm not going to look yet. So then, remember, we're learning numerator. Let's do the numerator first. 2 plus I times 1 plus I. If I FOIL this, I get 2 plus 2I plus I plus I squared, which is 2 plus 3I plus -1, which is 1 plus 3I.
This is pissed me off.
Oh, Matt. I'm glad you're trying, even though you're the aide. Okay, so keep trying. 1 minus. See if you got the bottom right though. 1 minus I.
Yeah.
1 plus I. Guys, I'm recording still. So I get the difference of 2 squares, which is 1, and I, which is 1 minus -1, which is 1 plus 1, which is 2. There's my denominator. But I'm not done yet. Equals 1 half plus 3 halves I. Done.